Hey guys, in this video we're going to be talking about what's the next biggest thing after AI. So obviously in the 70s they had cars, in the 90s it was the computer, in the 2000s it was technology kind of preceding, going after all of that, exceeding all of that, and for the 2010s it was social media, and 2020s it was AI. But what's the next big thing after that? Okay? So basically there's going to be three big things, but I think there's going to be one that's directly after AI, which will be the next big thing, and then the other two will probably come after that. But it's hard to really predict these things. Those two could come before or in parallel with it as well too. So the next big thing that's already kind of starting to take off a little bit, getting in preparation for it, because as we know, AI was created in 1950, just like pickleball, but neither took off till the 2020s. So the next big thing is going to be quantum computing. Okay? Now, whether you're investing in stocks or whether you're whether you're actually trying to use it for practical applications, research, for betterment of the world, for salary, or even just for job related, just like AI is. You don't have to be in research to have to know AI for your job. The next big thing is quantum computing. And before we go anywhere, guys, as you know that I have a lot of sports stuff on my channel, because on my channel for this specific one, I do everything. Okay? So then the just to get this out the way, I am not a Bears fan. I just like Brian Piccolo. As you all know, I am an Eagles and Titans fan. Now that that's out the way, and we're watching basketball and hockey for the conference finals right now as well too. But I got to get this done. So for quantum physics, and I'm going to read a little bit off my notes here because from what I know from it, I just wanted to write it down to have a clear script. To have a clear time kind of saying this. I don't read off a script. So quantum computing basically is an advanced field of technology which talks about the concepts of processing information using quantum physics. Okay, so you're processing information at a different rate than a regular computer, and by doing so, you're using quantum physics to make this happen. Okay, so now what is quantum physics? Okay, so quantum physics is a stem of science or a branch of science, whatever you want, which goes over both matter and energy, matter, doesn't matter which is first, the behavior as a fundamental, at a microscopic or fundamental level. Okay? So, something that would be an example of this are subatomic particles, which the rules of physics on everyday basis do not apply for. So, and also the scale of atoms. Since at a tiny scale, like I said, the everyday laws of physics do not apply to them, but also the because they do not behave like particles, those tiny scale particles do not behave like particles at that level, they also behave like waves. So particles behave like particles and waves at that level. Okay? So kind of an example that we're just going to keep this broad. We're going to go in more depth in another video of quantum computing. But start looking at stocks right now that are, like IBM. They already got the patents for certain parts of quantum computing and a $2 billion government grant as well too. So you might as well look into companies that are going to be going up in investment, because just like Nvidia, there's going to be Nvidia wasn't the only one. There's going to be companies that pop up. Okay, so for long-term holds, I like to usually say things like Lucid will be a long-term hold, but that's separate from the quantum computing stocks that are going to go up. Okay, maybe the two will be connected one day because there is a computer inside, obviously, an electrical car system, as there isn't one in a gasoline system as well too. But that's a whole nother topic for another time. So an example of quantum computing and how it thinks kind of is, right now a computer reads binary as ones and zeros, but the way they appear on the screen is different for quantum computing, which constantly feeds them out and spits them out at 101010 as opposed to next to each other. So that's going to be very difficult to understand, but it's almost like a coin flipping at 1 to 0, 1 to 0, 1 to 0, as opposed to coins stacked next to each other as 0, 1, 1, 0, whatever. Okay? So we'll talk more in the next video. And then there's two other things that are going to probably pop off as well too. They could be after, they could be in parallel. We'll talk all about that in the next videos.